Okay, so here's the second example. You can see that these are expanding questions again because there's a constant in front of the brackets that's going to have to be distributed to all of the terms inside the brackets. But right away you can see that what is more complicated about these questions is that they involve fractions. So our process is going to be exactly the same. We're going to take the number that's in front, multiply it with all the terms inside. Our thinking for pluses and minuses in between is going to be the same. The only thing that's going to be different is that when we're multiplying the numbers together, they're fractions, so we're just going to be multiplying fractions together. So if you take a look at the first one, you've got negative 1/3 times 24x minus 9. What you're going to be doing is you're going to be multiplying that negative 1/3 with both of the things inside. Now, in the last questions we did, we eventually just started multiplying in our heads, and we didn't really show the things that we're multiplying together every time. For fractions, you're going to want to show it every single time because you need to think about multiplying numerators and denominators, and I think the safest way to do that is if you actually see them next to each other. So let me just show you what that's going to look like. I think I have the step over here. Yes, here it is. Okay, now as you're writing this down, make sure you think about where all the parts come from and that it makes sense to you. So first we've got that negative 1/3, which is multiplying with 24. Now you'll notice I wrote the 24 as 24 over 1, so that in a second when I go to multiply them, I can think about multiplying numerators and denominators, which is how we multiply fractions. You'll notice here in the middle that I've got a plus sign. The reason why I have that is when you think about multiplying negative 1/3 times negative 9, negative times negative makes a positive. So I thought about that first and put the plus sign there. Then you've got 1/3 times 9, because you've already used up the negative in the plus sign, so it's just a 9, which I'm writing as 9 over 1. So then once you've got these guys, the next thing you're going to do is just multiply straight across tops and bottoms, like you always do when you're multiplying fractions. So what we're going to have from here, negative 1 times 24 is negative 24. 3 times 1 is 3. That's your coefficient for x. Plus sign stays. And then multiplying straight across tops and bottoms, 1 times 9 is 9, and 3 times 1 is 3. Okay, so now you've done the multiplication, and you can probably see by looking at these that these fractions aren't in lowest terms. So anytime you're dealing with fractions, whether you're told to or not, you need to make sure you put them in lowest terms at the end. Excuse me. So you'd be looking for a number that divides into top and bottom if it weren't for the fact that in these fractions, the denominator is evenly divisible into the numerator. So you're just going to think about 24 divided by 3. That's going to give you negative 8. That's your coefficient of x. And then 9 divided by 3 gives you 3. Now, it's not always going to happen that you've got a fraction multiplying in that gives you whole numbers at the end. The reason why this works is because 24 and 9 are both evenly divisible by 3. But sometimes that's what's going to happen. Okay, let's take a look at the next example, B. You've got 1/2 times 8x minus 5/6. What you're going to be doing is you're going to be multiplying that 1/2 in with both fractions inside the polynomial. And anytime you're multiplying fractions or doing any sort of operations with fractions, actually, one of the things I recommended to you guys was to get out of mixed fractions and into improper fractions, especially if you're multiplying, because you need to think about multiplying numerators and denominators, and it's hard to see what the numerator of 1/2 is when it looks like that. So one of the first things you're going to do is you're always going to change mixed fractions to improper fractions wherever you see them in a question like this. Do that as your first step, and then think about multiplying stuff in. So what that's going to look like for this one, whoops, that's not it. There it is. Okay, so you notice I made a couple of changes in this first line. I changed 1/2 to 3/2, and then while I was at it, I changed 8 to 8 over 1, because I know I'm going to be multiplying those together, so I just wanted to think about having that as a fraction. Now, I'm guessing that some of you are looking at this and thinking that you might be able to think about multiplying numerators and denominators without showing what was the green step in the last question. If you're really good at fractions and can keep track of what you're doing, that's okay with me if you get the right answer. Just be really, really careful if you're trying to do that for these questions. If you're going to show the step where you're showing them multiplying together, the thinking that you're going to do is as follows. You're going to think about multiplying first 3/2 with 8 over 1. And that's going to give you, if I write it out, actually I won't, let's drag it out from here. That's going to give you 3 over 2 times 8 over 1. That's your new coefficient for x. Then you're going to think about multiplying 3 over 2 with negative 5/6. That's a positive 3 over 2 times a negative 5/6. So positive times negative is negative. That's why I have this subtraction sign here. And then I'm showing 3 over 2 times 5 over 6. Then you're going to think about multiplying numerators and denominators together, like we always do when we're multiplying fractions. And then for this one, what we're going to get, if I write it out, we get 24 over 2. That's your new coefficient for x. And then your constant term at the end, because there's no variable, we call it a constant. 3 times 5 is 15. Whoops, that's a 5. And 2 times 6 is 12. Okay, often at the end of these, you're going to have to do some reducing, and that's the case here as well. When you look at 24 divided by 2, that's evenly divisible, so you can just divide it out and get 12. If you did divide top and bottom by the same number, you'd get 12 over 1, which isn't wrong, but it's just kind of awkward to write it like that when you can just write 12. Then you're looking at 15 over 12. You're thinking about a number that goes into the numerator and the denominator. That number's 3, of course. So then 15 divided by 5 is 3. Sorry, 15 divided by 3 is 5. And 12 divided by 3 is 4. So 12x minus 5 fourths. Now, if at this point you wanted to change 5 fourths into 1 1/4, you could do that. But the improper version of that fraction is okay as well. Okay, so that's it for these. The corresponding workbook page will be assigned to you. Please make sure that you check every question after you do it. And if you don't understand where things come from, particularly the pluses and the minuses, make sure you ask. It's important that you learn to practice this correctly.